So you'll have your first test on Friday, and it will pretty much dominate your grade because it's 75% of your grade versus all the homework we've done is 25%. So if it goes well, you'll have a good solid grade till the next assessment, which will be roughly a week later. Yeah, probably about a week later. And then if it goes poorly, you'll have that grade also. So hopefully you're kind of keeping in your notes, studying, looking over homework that we've done in the past. You'll need to be able to solve quadratics on there, like this one, as well as distance and midpoint, and I'll talk to you about a bunch of other things as well. So this one, remember, there is a BA or a BX term in this case, so we do need to get the whole thing set equal to 0. So if we add 7a and subtract 3, so 3a plus 7a is 4a, and then minus 3, and that whole thing now is equal to 0. Good so far? Okay. Now let's set up the star, and we need to know that the top is a times c, the bottom is b, and then on the top of the sides is a. And just to review, a is the number out front of x squared, b is the number out front of x, and c is the number with its sign that's just by itself. So a times c is negative 45, so 15 times negative 3. And then b is 4, a is 15. And now we're looking for numbers that multiply to make negative 45, but add up to positive 4. So are there numbers that do that? Yeah, so for 45 we have 9 and negative 5. So 9 minus 5 is 4, 9 times negative 5 is negative 45. So those are the two that we'll use. I did forget to mention before we started the star, we should look for a GCF for each of those, and in this case there wasn't one, which is why I didn't say it, but don't forget to look. Okay, now we need to simplify these sides if possible, and they both do simplify. So what goes into both 15 and 9? 3 does, so we have 5 and 3. On that side, what goes into both 15 and 5? Okay, so we get 15 divided by 5 is 3, and negative 5 divided by 5 is negative 1. So both sides had to be reduced this time. Okay. Now we go write those as factors with the top number with x and the bottom number just with its sign. So this will be 5a and then plus 3. And the other one, 3a minus 1. And we're solving, so this is still equal to 0. Okay. At this point we use the zero product property and we say if these two factors multiplied make 0, then one or both of them is 0. So we go figure out where that happens. We say 5a plus 3 and we set that equal to 0. Same thing on the other side. And now just solve each of these little mini equations for a. So on the left, just subtract 3, divide by 5. And sometimes you get to the point where you can see these answers without showing the steps, which is nice. But it's good practice. Divide by 3, we get 1/3. Okay, so this is just a naked math problem, meaning no context, no story, not even geometry context. So those are our two solutions algebraically. We have negative 3/5 and positive 1/3. If this was a geometry problem, which of these would probably not work? Or potentially, I should say, not work. Like which one would you have to kick out? Yeah, probably. We'll see that today. Alright, distance and midpoint will be on your test. It's one of the things that students sometimes mess up because you're not careful with your procedure, your arithmetic. let's start with distance this time. Remember, your formula comes first, and it's just the the Pythagorean theorem. So x2 minus x1. Probably a good idea to get the coordinates first. This is 4, 0, and this is negative 5, 1. Okay, so 4, I would say 4 is the x2. So 4 minus negative 5. And then y's would be 0 and 1. So that's just talking through potential pitfalls with this. That's the first place. People mix up x and y. Like maybe put a 4 with the, instead of with the 5, they put it with the 0 or something. Next possible pitfall is the subtraction. 4 minus negative 5 is 9, not negative 1 or 1. And then of course 0 minus 1 is just negative 1. Okay, third possible pitfall, and this one comes up fairly often because if people are trusting their calculator without using number sense, they blow it. This negative 1, when we square it, becomes what? Here's what I mean. They go to their calculator and they're like negative 1 squared. Oh, that's negative 1, and their number sense is off, meaning their understanding of the basics is off. What should it be? When we square something, what is it always? Positive. Okay, so this is 81 plus positive 1, and we get 82 square root of 82. Okay, and then the last thing that I've seen students do fairly often is somewhere along the way they just quit writing the square root. And so their final answer ends up being just 82. Is that correct? You know, like somewhere back here they start dropping that off, and it's like, uh-oh. That's not okay. It needs to stay on there all the way through. Okay. And then for midpoint, again, you have two options. On the tests, one of the problems has a graph like this, and the other doesn't. And so you'll need to be able to do it either way. Oops, it's too far down. You can count and just figure out the midpoint that way. In other words, we went down 1. So the midpoint will be down a half, and then we went over 9, so the midpoint will be over 4. So over 4.5, excuse me, and down 0.5. Okay, so down 0.5 from 1 is 1/2, or 0.5, and then to the right, 4.5 from negative 5 is negative 1/2. And I actually have these backwards. Excuse me, let me fix that. Okay. Algebraically, those of you who like formulas, your midpoint is just the average of the endpoints. And A and B, remember, are just representative of the endpoints. It's not going to be labeled A and B every time. So XA is negative 5. And xb is 4. Negative 5 plus 4 is negative 1 over 2. So there's the algebraic way to get the negative 1/2. Okay, same thing with the y's. I'm not going to rewrite this because it's the same. So we have 1 plus 0. 1 plus 0 over 2, which is just 1/2. Okay. So whichever way you like to do those, I don't care which way you do it. Be able to do it though. So, any questions on your warm-up? I know actually a lot of you didn't do the whole thing, but maybe go back and review if you need to. Yesterday, so grab your notes next. Yesterday we talked about these angles. Let's do a quick review of them, add a few more, and then some practice problems. So we talked about complementary angles add up to 90. Supplementary angles add up to 180. We're going to use those pretty often. I should have put a star by vertical angles because we definitely use those a lot. Vertical angles, remember, have nothing to do with being up and down. They are any two angles that are back to back facing exactly opposite. So we saw like A and C, even though they're not up and down, A and C are vertical. And so are B and D. And they are congruent. That's the nice thing about them, is we can copy and paste. Okay, we added right at the end. So we started packing up. Scroll down. So you may not have got this. We added linear pair, which are two angles that are next to each other, and they make a straight line. Okay, because they make a straight line, they add up to 180. So I said in the figure above, this green figure up here, we had lots of different pairs, A and B, and then if we just work around, we had B, C, C, D, D, A. All of those are linear pairs. The classic look of this is a straight line with some stick or piece sticking out of it, kind of. Okay? Now, you might have to look closely at these if they are inside of another figure. And I'll show you that here in just a minute. Now, we do use linear pairs a lot as well. So vertical and linear pair are the two biggest ones. Supplementary, probably the third. So here's some of these problems that we can encounter with these angle types. There we go. Okay. So what kind of angle pair is this? Those are vertical. What is true about vertical angles? They're what? They're congruent, right? So we can, what can we do with these to solve for x? Yeah, if they're congruent, they're equal, right? So we just set these two expressions equal to each other. Now we have this basic simple equation to solve. And let's do that real fast. And then add your 45, divide by your 2, and x is 25. Notice the directions don't just say solve for x though. They also say find the measure of the labeled angles. So what do we do with this 25 to find that? Yeah, we gotta go plug it in, right? So maybe plug it here. 4 times 25 plus 5 is 105 degrees. Okay? So I think the solving is easy. It's again with geometry, guys, as I've told you all year and will continue. It's knowing which geometry relationship to use in order to solve. Solving is generally pretty easy. So, vertical angles. Let's skip that one for a moment. What kind of angles are those?
Vertical.
Those are vertical as well, even though they're oriented slightly different. How about all of these?
Vertical.
They're all vertical. So here's a question. What if I wanted to know, in fact, let's put one of these maybe in an example. So I'm going to grab this. No, that's not what I wanted. Oh, by the way, we're going to get to a picture like that. Do you see all the vertical pairs, all the linear pairs, right? There's a bunch of stuff going on here. And you'll have to find all these different labeled angles all over the place. So, like I told you, this comes up a lot. We will use these angles a whole lot. But let's get there maybe next week. So go ahead and sketch that picture in. I'm going to modify the question from what it looks like. I want to know what is the measure of angle QTS. And this is a pretty typical problem from geometry that confuses students. Is measure of angle QTS, is it x? No. In other words, I can't just plop an x there and say, oh, that's my variable. No, because x is specifically involved with these two orange expressions. So what do you think? What's our procedure here? We need x first, right? So use the correct geometry relationship. In this case, vertical angles theorem, to set up and solve for x. Okay, so these are vertical angles. So set equal x plus 28 equals 2x plus 16. Okay, we'll solve that. Hopefully this is easy for you at this point. If not, you better come talk to me, because you are way behind. Okay, x is 12. Are we done? Okay, so step 2. Plug x in as needed. I mean, this is just general steps. I can't tell you how to do every problem because it could be a completely different picture, but generally this is what we're doing. So plug x in to get more information. Can I plug it in to get QTS right now? Oh, there's nothing there, right? There's nothing in QTS, but I can plug x in into one of these. So like here, we have 12 plus 28, which is 40 degrees. Maybe I'll just write that aside. Okay, so we now know this is 40 degrees. Now we can do this again. Use another correct geometry relationship to set up and solve, only this time we just don't have an x. Okay? So maybe draw like a cycle arrow. Okay? Repeat as needed. What kind of relationship does QTS have with this now known 40-degree angle? How do you know that? Nothing said it. What was it? Okay, it's a group. But what kind of angles are these two specifically? See what I mean? You guys need to study these angle pairs and know them really well. So this is a linear pair. They make a straight line. Okay? So 40 plus whatever QTS is equals 180. So the measure of angle QTS is what? 140 degrees. So you had to see the vertical angles pair to solve for x, and then see a linear pair to solve for the requested angle. And none of this was told to you, right? All it did was just have x's placed in there. So you had to know your geometry relationships in order to set those up. Very typical problem. And you guys have seen this somewhat with like segment and angle addition, angle bisector, stuff like that. Okay. Last relationship for this test. If we know two angles in a triangle, do we know if we can get the third? That's what this is asking. In other words, do we have a set number of degrees in any triangle? You guys, anybody heard of that before? Okay. Let's do an easy one. Let's say this is 100 degrees and this is 40 degrees. What is this one? Let's change this. It doesn't look like that kind of triangle. 130, and then what would this be? Okay? So we have a theorem called the Triangle Angle Sum theorem that says, yes, we do know how many degrees are in any triangle. And they all three add up to 180 together. And students often want to chop this in half and say, oh, hey, I only know 2, or I know 1 and I need the other one. That must be 180. No, it's all 3 together. So let's write the theorem down. Again, this will be the last theorem that we'll test on for this test. And it's called the triangle, and then you kind of say angle sum together. So triangle angle sum theorem. We will use this a lot too. So we're kind of establishing some foundational angle relationships. So the 3 angles in a triangle add up to 180 degrees. That's what this says. And I think it's worth even putting this is always true. It doesn't matter what size the triangle is, it's always going to add up to 180 degrees. If it doesn't, it's not a triangle. Even if it's off by 0.1. Okay? We're not going to like round or estimate. Okay? Here it is in some sort of a formula. So you can use that to solve for things. Again, it's a formula, so you always write both sides down. That way if I give you A and B, you can solve for C. Or if I give you B and C, you can solve for A, etc. Did anybody know that? Raise your hand if you knew that before. Okay. Just the back corner. Cool. So here's what these problems will look like, or versions of them. Okay? So you notice 2 triangles together makes 3 triangles total. 1, 2, and then the big one, 3. Okay, here's 2 next to each other, and again 2 that make 3. Okay. How could we solve for x? Eva, how would you solve for x? Okay, and when you say corners, are you talking about 78 or 57? Yeah, so she's looking at this right-sided triangle, okay? And it's always okay to peel off pieces and look at them separately. So we have a triangle with 2 known angles, so we solve for the third one. 32 plus 78 plus x equals 180. That's using that equation we just wrote. Okay, 32 plus 78 is 110. So how big is x? Okay, so 70 degrees is x. Now we know that. Now we need to find y. How do you find y? Look carefully. Look at all the angles we just talked about. We had complementary, supplementary, vertical, linear pair, and now the triangles. So look at y. There is more than one way to solve for it, but there's absolutely a better way to solve for it. Anybody seeing it? Well, it's certainly part of a triangle, right? Can we assume that I can copy this 32 right here? Yeah. Is that a safe assumption? Some people are saying yes. Do you have a geometry reason, a geometry theorem, postulate, or relationship that proves that that other side is 32? Were you told it's an angle bisector? Do you have the conditions of knowing that that is congruent? Okay. Do not make assumptions in geometry. It will bite you every time. Okay? No joke. It will bite you every time. It looks really darn close to 32, but that is not good enough. And in fact, we just proved these two angles are not the same. So it is, in fact, definitely not an angle bisector. So we know that it is not 32. So don't just make that assumption and drop 32 so you can solve for y. Anybody seeing a better way? Well, here's what you need to see. That is, even though it's part of a triangle, that is a linear pair. So what is true about y and 78? Yeah, they make a straight line. That QS is a straight line. So y plus 78 equals 180. So just subtract your 78 and you get 102 for y. That's the easiest way to do y. That isn't the only way. We could have figured out, if we look at this big triangle, we could use 70, 57 and find this whole angle by subtracting. And then subtract 32 to get this piece, and now we can work within the left side triangle. But that was extra work. I mean, it's okay if you saw that, but I think this way is a lot shorter. Okay, why don't you try these bottom two? Alright. It shows this arrow pointing just to the right side of the top angle. So how do we solve for x? Let's start with it. So I see, in fact, like I said, it's okay to zoom in on one part of the figure. And I see we have two angles and an unknown third within a triangle. So 35 plus 96 plus x equals 180. And of course we just add these and subtract from 180. So 180 minus 35 minus 96 is another way to do that. You should get 49. How about y? Again, can we assume that top angle is bisected? Even though it kind of looks like it. Okay? So if we zoom in on that triangle, it's kind of skinny. We have y, 77, and we don't know that one. So we have two unknown angles in that one triangle. So you have two options. You could use this one, or you can look at the bigger one. Now we know this is 49, this is 77. Then you would have to solve for this whole thing, maybe call it z, and know that z we'd have to subtract 35 from z to get y. So that's another option. Okay? Either one. If you're doing the skinny triangle, you should zoom in on this linear pair right here, and then know that 96 plus that other side. So if I zoom in, I have 96 and this angle. What kind of angle pair are those? That's a linear pair. They make a straight line. And so they add up to 180. So 180 minus 96 is 84. So this is 180 minus 96, which is 90 or 84. Okay, that goes right there. Now we have two angles that we can use to solve for y. So y plus 77 plus 84 equals 96. Okay? Sorry, 180, not 96. Again, we subtract those two. 180 minus 77 minus 84. Now we get 19. And it looks like it should have been a pretty small angle. Let's go. Again, we're not going to estimate. Like, we're not going to use our eyes and say, oh, that looks like it's about 20. We're just going to solve. But it makes sense. It's a pretty acute angle. How'd you do on that one? Okay, next one. I call this kind of a bow tie shape, and we'll see it in various scenarios across several units. It comes up fairly often. Which variable should you solve for first in this case?
X.
Yeah, because we have two known angles in this right-sided triangle. So x plus 57 plus 59, that gives us 180 inside this triangle. So we'll subtract both of those. 180, that's 18. 180 minus 57 minus 59. Okay, so it is 64. Okay, what can you do with it to get y? These ones are kind of nice, sort of. Again, you have complementary, supplementary, vertical, linear pair, and all these triangle angles. Do you see any of those in here? Yeah, is it?
Vertical.
Yeah, right here, these two are congruent. They are vertical angles. Even though there's nothing marked there, guys, don't worry about if it's marked or not. If you know for sure, based on the geometry property, that it is true, like this is for sure a vertical angle, then put it there. It doesn't have to be marked. Okay, now in the left side we have two angles, so 42 plus 64 plus y also equals 180, because that's now in this left-hand triangle. And we just go subtract 180 minus 64 minus 42, and we get 74. How'd that one go? Right. How about this? Measure of angle 1. By the way, this is, I think, our first look at a numbered angle rather than a letter angle. So just know that sometimes we will put a number inside of an angle instead of a letter. And it's fine. It's just a different way of naming. So what is the measure of angle 1? How do we find that? What relationships do you see present, even though if it's not marked? Okay, you gotta say both words. Linear. No. Linear. Linear pair. Guys, Parker's carrying the load for you guys. More of you should say stuff. It would help you engage better. Thank you, Parker. But yes, linear pair right here. So what do these two angles add up to? The dot and the 1 add up to 180. Okay, but we don't know the dot and we don't know 1, so we're not quite there yet. But we could find the dot angle by doing what? Okay, so it's just another triangle system, and we're just going to add those together. Okay, so 180 minus 75 minus 45, and so that dot angle is 60. And now we can find measure of angle 1, which is what, Morgan? Kind of figured. How about you, Alexis? Can you help us out? With what?
With 180 as well.
Yeah, good. Because what kind of angles are these? Linear pair. So we can write it as the dot plus measure of angle 1 equals 180, because they add up. They're a linear pair. They add up to 180. We just found the dot was 60 by using the triangle angle sum. So what's the measure of angle 1? It is, just subtract 60, 120. Now, what's cool, there's a separate theorem. You don't have to use it, because we just showed that we can find a measure of angle 1 without it, but it is the sum of these two opposite angles. So 75 plus 45 is 120, and that will always be true. If you have, this is called an exterior angle. It is the sum of these two interior, opposite interior angles. So if I show you a few more of these, like this 109 is the sum of these two. So 109 equals 51 plus measure of angle 2. Same thing over there. It's called the triangle exterior angle sum theorem. You don't have to use it though, but I'm going to write it. I know I said that was the last one. There's actually a couple that I forgot to tell you, but again, this is an optional one that it makes solving convenient, but it's not needed. So basically, if we extend one of the sides of a triangle, it makes an exterior angle. So the measure of angle x equals the measure of angle A plus measure of angle B. It cannot be this one right here. It has to be the opposite interior angles. So let's put that in words too. Exterior angle equals the sum of the opposite interior angles. It might be useful, but again, you can use the triangle angle sum, the fact that all those angles add up to 180, and the fact that there's a linear pair right there to get around this. You can do that as well. Okay. I handed you that sheet. Once you're done writing this, go ahead and grab it and look at the first problem on there. Amy, when she comes back, we'll make sure to help her with this. Thanks. Alright. So I think I passed that one. Yep, here it is. Okay, thoughts on how to do this one? You will have something like this on your test. So this is kind of the whole picture, meaning it's somewhat difficult solving, and you have to know the appropriate relationship to even set it up in the first place. So I think it depends somewhat on the person, but I would say this is about as hard as the problems get on this test, roughly. Okay? Depending how well you know your theorems. So thoughts, what are we given, what do we know, what are we trying to solve for? Eva, how about you? Yeah. So eventually we need x, and then we eventually need those three angle measures. That's what those blanks mean. And then what relationship are we going to use to set up to solve? Peyton, how about you? Peyton. What relationship will we use to set up an equation to solve for x? Nathan. Aiden. I mean, has anybody actually looked at it? Because there's really only one going on here. So what are we given? What is it in? What's that relationship? I'm not like looking at a whole bunch of different stuff in this case. Which one is it? C. What do you mean by that? I'm asking for the geometry relationship. So is this segment addition, angle addition, distance formula, midpoint formula, angle bisector, perpendicular bisector. Is this complementary angles, supplementary angles, vertical angles, linear pair, or triangle angle sums? Those are the big ones we've studied so far this year. Okay? If you cannot list those or have a lot of confusion about what those are, this is why I tell students, study your notes every day. Like, just go read them. Because we have a lot of this, and we're not even done with one unit yet. Okay? These that I just mentioned will come up in almost every unit. So it's not like you can just forget them. You also can't just go home and play video games and not study this. You won't have success. Yeah.
So the triangle angle sum?
It is triangle angle sum, which says what?
So all three colliding.
They all three add up to 180. So write with me, x squared plus 11x plus 38 plus 11x plus 38 equals what? 180. Okay, what now? That is the end of the geometry step for the moment. That is the triangle angle sum, and now we're ready to do algebra for our next minute or two. So at this point, you switch your brain and say, okay, I see a bx term, so what do we need to do?
Add.
We need to get it set equal to 0 and factor, okay? And yes, we do need to combine our like terms. So let's say x squared plus 22x plus 76 equals 180. Okay, that's just combining and cleaning up, but now we need to get this set equal to 0. Again, we're in algebra mode. If you're looking at this and have no clue, that's a concern. Come talk to me before Friday. Okay, so 76 minus 180, what is that? I think negative 104. Let's just double check so we don't get on the wrong path. Okay, so we're looking now to factor this. A times C, B, A, and A. A in this case is 1, which is awesome. That makes this easier. A times C is negative 104, and B in this case is 22. Looks like I dropped my X. Sorry about that. Okay, are there factors of negative 104 that add up to 22? So they're probably got to be kind of close together, right? Now, if they're not, then we're going to have to do this a different way, but like quadratic formula. So factors of 104. There are not a lot of them. I'm just going to try 4, and I get 26. Does 4 and 26 make 22? Yeah. Okay, so that was kind of a good guess right away. So we have 4 and 26. Which one of those needs to be negative? Because we have to make negative 104. The 4 does. Good. Okay. We can't reduce because both of these are already 1. So we are ready to just use both factors. We'll get x minus 4 and x plus 26 equals 0. And then here's that 0 product property where we set each equal to 0 and solve. We'll get 4. And we'll get negative 26. Okay. Do they both work? Look at your sheet. Can I plug in 4 and make sure that all 3 angles are positive? Does a positive 4 work? Let's check. Well, 4 squared, yes, that's positive. 44 plus 38, that's positive. So the 4 definitely works. How about the negative 26? Well, negative 26 squared is positive, but it's more than 180 degrees already. So that doesn't work, right? And then also down here, if I plug in negative 26, those angles would be negative. So this is not an answer. Kick it out. it makes negative angles. Okay? So even though we got two algebraic answers, they are not both okay geometrically. So we take 4, okay, this is now x. We are going back to geometry world to solve for these 3 angles. So we know that measure of angle ABC, that first one is what? 16. It's 4 squared. Okay, BCA. So now we're going BCA, this one over here. So that is 11 times 4 plus 38. By the way, you hopefully are noticing if you don't have a calculator on Friday, you will most likely fail this test. 82. Okay? Why didn't I plug it in on CAB? Like, why didn't I rewrite that out? You see how it's the same thing? I don't need to do it twice, right? Now, if it had a different expression, obviously you would. Okay, that's a pretty typical triangle problem. Questions? So your test on Friday will involve segment addition, angle addition, bisectors, which includes angle and perpendicular bisectors. Make sure you know when it's an angle and perpendicular bisector. It will involve midpoint, distance, linear pairs, vertical angles, triangle angle sums, and quadratic solving along with all the linear solving. You should